Okay, I'm going to make a short video about 8-4 and 8-5. These are specific kinds of quadrilaterals. In 8-4, we're going to talk about rhombuses, rectangles, and squares. These are already in your notes. I just want to explain them so that they make sense. So I want you to see that they are parallelograms, and we talked about that last time. So you should already know that all three of these figures have opposite sides parallel, opposite sides congruent, opposite angles congruent, and consecutive angles supplementary. That was from our previous lesson. Down here with the stars, these are new information for you today. So a rhombus fits all of this criteria and four congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. So I added those new stars in the picture below. I think those are pretty self-explanatory. A rectangle, again, it's a parallelogram. It has two new features. It has four right angles, and the diagonals are congruent. So this length is the same as this length. A square has lots going on. So a square also is a parallelogram. It has all of these features. It has four congruent sides, four right angles. It is a rhombus and it is a rectangle, so it has everything. It also has the diagonals that are congruent. It has the diagonals that are perpendicular, and the diagonals bisect opposite angles. So just about anything you can imagine a square has. So what I did was consolidate everything that's in these little green boxes into this area here for you for easy reference. I want you to see how things fit in together. Parallelograms in general, we talked about last time. They're four-sided figures. They're closed figures. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. That's these two figures here. Getting more specific, rhombuses will fit into this blue square, or blue oval, I should say, and these are example of rhombuses. This orange circle or oval, these are all rectangles because they have the four right angles. So squares fits both of those criteria. So I don't really want to go into examples because you really just have to apply the information that's given to you. Here is one quick example. It says for any rectangle EFGH, it is always sometimes true that FG and GH are congruent. Well, if you look at my picture, because they didn't give one, I drew the picture. They want to know if these two sides will always or sometimes be true or be congruent. That's always. Because if it's a rectangle, it has to be a parallelogram. And the definition that we learned about parallelogram is opposite sides have to be congruent. So this one isn't always. Number 2, it says a quadrilateral has four congruent sides and four congruent angles. Sketch the quadrilateral and classify it. This has to be a square. There's no other figure that has four congruent angles and four congruent sides. It has to be a square. These new theorems, again, I've posted those above in the summary that I wrote. Couple of problems that I need you to do using that summary that I wrote that should not be too difficult for you. 8-5, these are properties of trapezoids and kites. These are not parallelograms. So the three that we just talked about, rhombus, rectangle, and square, are parallelograms. Trapezoids and kites are not. And if you look at my examples here, this is again a summary of everything in this section. This figure, trapezoid, it has one pair of parallel sides, exactly one pair of parallel sides. So it's not possible to have exactly one pair and to be a parallelogram where it has two pairs. It's just impossible. So a trapezoid in particular, which makes it a trapezoid, is that it has the one pair of parallel sides. An isosceles trapezoid gets a little bit more specific. So it's still a trapezoid with one pair of parallel sides, but it goes a step further. Each base angles are congruent, the legs are congruent, and the diagonals are congruent. That's not the case with a regular trapezoid. So these black lines through the middle, those diagonals are congruent. Base angles are D and C, or A and B, depending on how the figure is drawn. These are summarized above, so I've already done that for you. With trapezoids, there's the Midsegment Theorem. So, and this is as simple as I can make it for you guys. So a midsegment, we've already learned, connects two midpoints of the legs of a trapezoid. To find that mid-segment, you average the two bases. And you can figure out where the bases are because those are the ones that are parallel. Notice these are not parallel, those are the legs. These are parallel, and those are called the bases. So to find this length, you add these two and divide by 2. Kites. These are four-sided figures. They are not quadrilaterals. This is what a kite has going on for it. Two pairs of consecutive congruent sides. Consecutive means next to them, next to each other. So if you look down here at the bottom, these two are consecutive, they're congruent. These two are consecutive and congruent. Opposite sides are not congruent. That's important. These two sides are not congruent. That's important. It specifically says that. Diagonals are perpendicular, and there's only one pair of opposite angles congruent. Typically, when you have a very traditional kite, these two are the ones that are congruent. Typically, this angle and this angle are the ones that are not congruent. And if you just look at that, that should make sense to you. So a kite is kind of a standalone. It's very different than a lot of the other figures that we were talking about. But again, these are the features that I want you to know. So again, there's some problems here that I'd like you to do using those characteristics, and I need you to let me know if you have any questions.